Get some. Do tomorrow because there's one like this on it and it's really scary.
Okay.
So.
Yeah, because I was gonna ask you to tell me where
Yeah, you get an extra day on it anyway. So take the time you need. Okay, I'd rather you do it right than get it in fast.
So does that mean I turn it?
You can turn it in Friday if you need the time.
Alright, thank you.
All right. This is the hardest one today, by far, by lots and lots and lots of steps. And the only reason we're doing this is because there is one like this on the homework, okay? This is the 1-4. So this is the hardest question in Unit 1, and then we're about to look at Unit 2, and it'll be in the very, very easiest questions of Unit 2. I promise, like, it's going to be a big old shift. Okay, this is by far, orders of magnitude, the hardest one we're going to do today. Okay? And we kind of started it yesterday. What we're going to do is we're going to look in here, and I see that I have a negative exponent over here. So we're going to deal with that first and make this guy a fraction. Because we know this thing is going to be, that is not what I wanted. Stop making me draw a line there. We're going to take this whole piece and make it a fraction. We're going to have our x squared minus 4 to the 1/2. If you want to put it as a root because you like roots better, you can absolutely do that. Remember, a fraction of 1/2 means it's a square root. You can do that. I'm going to leave them as fractions. But if you like them better as roots, you do you. So that's this piece. This piece went into the denominator. And I'm just going to bring the other pieces down. We have 2x plus 1 cubed. I have 1/2 times 2x. The 1/2 and the 2 cancel, and we just have x. Are we okay on that part? I think that's about as far as we got yesterday. We just simplified that. On the left-hand side, pretty much the only thing we could simplify here is the 2 times 3. These two guys. We can make that 6. And then everything else is still the same. X squared minus 4. That's a minus. My pen's being a jerk. There we go. To the 1/2. And then we have 2x plus 1 squared. We want to be able to add these together, which means they need to have a common denominator, right? So we're going to take our very, very unfriendly denominator, and we're going to multiply this term by 1. It's just ugly. So we need to take this whole piece times x squared minus 4 to the 1/2. My pen is being a jerk. X squared minus 4 to the 1/2. That way we get the common denominator. Kind of see that? When we do that and get to the common denominator, I have x squared minus 4 to the 1/2 times x squared minus 4 to the 1/2. Yeah. So we have here, oops, x squared minus 4 to the 1/2 as our common denominator. And we're going to have a beast here. And this is going to be 6 times x squared minus 4 to the 2 halves, or to the first, because we had times to the 1/2 to the 1/2. Right, okay. And then we have 2x plus 1 squared. Plus 2x plus 1 cubed times x. All in one fraction. Yes? Not the worst thing. We have more. We're not done yet. We're going to try and factor the numerator. Look at all the individual pieces. Is there any individual piece they share? Between the thing here and this thing here, the numerator. 2x plus 1. How many 2x plus 1s do they share? 2. So we can factor out in our numerator here. I know, these are gross. 2x plus 1 squared. And the pieces left over are 6x squared minus 4 plus x times 2x plus 1. Lots of pieces, lots of pieces. And I put both of those things in front. Okay. Still over that same denominator that's gross. Does everyone see where that came from? What's up? So the 2x plus 1 cubed, I took 2 of them out. Yeah. And so we have this one left over. Then this guy looks gross. Super gross. We are going to get rid of all of these parentheses inside. We are going to distribute that out. Okay? We're almost done, I promise. It's super close. So this guy's still going to hang out front. Our 2x plus 1 squared. Our numerator is going to become 6x squared minus 24 plus 2x squared plus 2. Or no, plus 1x, sorry. Plus x. Right? We see where those pieces came from? Minus 4 to the 1/2. Okay? The last piece is to simplify that green blob, because right now he's ugly. Get our x squareds together, put it in our normal trinomial order. You got a question mark floating above your head. You got it? Okay. Just checking. Sometimes it's like a sim, and I can see the question mark floating above your head. So all we got to do is simplify this, and then we're done. We can turn the page and walk away. Like, we get a mic drop moment after this. 1 squared. And this piece, we have 6x squared plus 2x squared, giving us 8x squared plus x minus 24 all over x squared minus 4 to the 1/2. And we thank the book for not asking us to rationalize. It just said simplify. So the fact that there's a root in the denominator, oh well. That is the answer for that. Yes,
I don't entirely get why that's the point you stop at.
There's not any more factoring we can go. I cannot factor this guy. If you want to write this out long ways, we can. We're just trying to factor it and simplify as much as we can. If you're really feeling froggy and you want to rationalize, more power to you. It's going to add another like 5 lines. Okay? If it just says simplify and it doesn't say rationalize, don't worry about it because they're gross. Okay? What's up, Lincoln?
So we can leave the square root.
Yes, as long as it doesn't say rationalize. If it says rationalize, you got to get rid of it. Go ahead. Uh-huh. I'm coming. Yes. What's up?
So, like, I understand this whole thing, like,
Mm-hmm.
this part from this, I just don't know how you this part from this part.
So from here to here, we multiplied by that denominator to get our common denominator, right?
Mm-hmm.
The x squared minus 4 to the 1/2 times x squared minus 4 to the 1/2 gave us x squared minus 4. 1/2 plus 1/2 gave us 2 over 2. Okay. And then from here,
So they cancel out.
so from here, so it becomes x to the first. Yeah. So then, to get from here to here, we pulled a GCF, a common factor of 2x plus 1 squared.
Oh.
This one's cute, by the way. Just so that-
Oh, okay.
Okay.
Okay, thank you.
Uh-huh.
Can you, like, go back up a few steps, because I got confused a long time ago.
Where'd I lose you? That's the whole thing.
Okay, so I was with you when we multiplied
Uh-huh.
basically over 1,
Uh-huh.
and then I'm trying to figure out how did the exponents disappear. And
So
then-
1/2, so when we have that same base, x squared minus 4,
okay.
the same base, think of it as x to the 1/2 times x to the 1/2. What happens to my exponents?
They cancel out.
We add them together, and we get 1/2 plus 1/2, so we get x to the first. So x squared minus 4 to the first.
Okay, and then
And that's all the other pieces there.
And then the 2x plus
Mhm.
1 to the third,
Mm-hmm. This one.
where did that go?
So we pulled out from this set, we pulled a greatest common factor of 2x plus 1 squared.
Okay.
Because this has a 2x plus 1 squared, this has 2x plus 1 squared in it. We just had a leftover,
Okay.
and we pulled it out as a GCF.
Oh, okay.
Okay? So it was like factoring. Gross pieces, but factoring.
Okay.
Okay? Yeah. This down here? Ah, that was x times, my pen's being a jerk. X times 2x. X times 1. Yep. Yes.
So you know how in here, on the x squared minus 4, both have the same, but here, the 3x plus 2 has 1 over 3, and this one has negative 2 over 3.
So just like, so when that goes into the bottom, it'll be that to the 2/3. We want to multiply to get that common denominator. So we're going to multiply by the 2/3. We'll wind up with another situation like here, where we're going to add our exponents together, and we'll have 1/3 plus 2/3.
So I'm gonna
and it's still going to cancel
I'm
out.
gonna add on both sides. So on this side, I'm gonna multiply by 3x plus 2 over negative 2, like with this here.
So put it as a fraction first, and then get to a common denominator. And just have faith that that's going to work, because it is going to work. Okay? All right. So by far, this is the grossest one, because you're going to have a big old sigh of relief when we go to the next problem. I promise. We're looking at solutions, and we're going to solve stuff. You do not have to write these down if you don't want to. These should be words you know, and I left my coffee over on your table.
Oh.
All right, so an equation. This should be things we know. Equation is 2 expressions set equal to each other. The solution, or the root, is the number that makes it true. Right? That's stuff we've dealt with before. These are not new words, our equation or solution or root. That's fine. If you want to write them down, you write them down. But I promise you're thinking harder about it than you need to. Okay? Let's close the door. I should WD-40 that door. Equation just means it's going to have an equal sign. Solution is when we solve that equation. And we get x equals or b equals or r equals or whatever equals. Right? See? I told you by far the first one was the hardest of the day. By far. By far, far, far. To be fair, that's the hardest one I've seen so far total. I'm only like 6 lessons past you guys, but it's the hardest one I've seen, the one we just did. Okay, so all we're doing here is we're going to solve these. Remember, it's just whatever you do to one side, you do to the other. Right? We've seen those that way before. So what are we going to do on this one? What's our first step? Distribute. 4x plus 5 equals minus 6x plus 12. Then what? Add 6. X. We could even, at the same time, subtract the 5 to get us 10x equals 7. So x is 7/10. Lovely change of pace from that last problem. Lovely change of pace. Screen, can you not? Thank you. Oh, I'll leave it there. So then we're going to look over here. It's slightly harder, but you've done this before. In order to solve this, what are we going to need to do? Get rid of the squares. How are we going to get rid of them? Nah, square root. I've got addition over here. I can't square root both sides. So multiply them out. X plus 3 squared is going to give us x squared plus 3x gives us plus 6x plus 9 plus 5. X squared 2 times x gives us minus 4x plus 4. We are going to need to be able to multiply binomials. It's going to happen. If you draw a box, that's fine. If you want to write it out and distribute it, that's fine. You'll get to this. However you choose to get there. I love when I can't write on straight lines. Well, that's wonky. So what are we going to do here to try and get to a solution? Let's try and set it equal to 0. That's always a good idea when we see x squared. So let's move one of these x squareds over. What's going to happen? My x squareds cancel out, so we don't have to work towards 0 anymore. We get 6x plus 14 equals minus 4x plus 4 once my x squareds cancel out. And we're into something that looks a lot like the last one. So what are we going to do? Add 4x. And we can at the same time subtract it. You're right. And we get that 10x equals negative 10. So x is negative 1. All right? Not the worst thing ever. Familiar. Should be, hopefully familiar. We're going to keep going. They kick up a notch or two. So this one's the same kind of vibe. Before I start trying to add or subtract things to both sides, let's simplify each side. So we're going to have 2x squared plus 6x minus 5x minus 15. Whatever order you put it in is fine. X squared minus 6x plus 1. Distribute it out however you need. And again, I see an x squared, which means we need to aim to get this thing to equal what? 0. Yeah. So if we see x squared, aim to get it equal to 0. So let's subtract x squared for both sides. Sometimes I wait for more than one person to say it. I was like, I know I heard one person say it, but I couldn't tell who it was. And there's 29 of y'all. I sometimes wait for more than one person to have the idea. So we're going to have x squared. So they're not canceling out. So we're going to move everybody over. We can do it all at once. Plus 6x. Plus 6x. 6x minus 5x plus 6x gives us 7x. And then we're going to subtract 1, minus 1, minus 16. So you can do it kind of all in one go. As long as you can keep your thoughts organized, I don't care how many steps we do at once. That's fine. If you can keep it organized, great. If you need to write that out in more steps, totally fine. How can I find this solution? Factor it. We always hope for that. Let's see if we can do it. A times c at the top, 1 times negative 16. So we have negative 16 on the top. B on the bottom is 7. Do we have a pair of numbers that multiplies to be negative 16 and adds to be 7? Dang it, right? It's not factorable. What can I do then? Quadratic formula! X equals negative b plus or minus the square root b squared minus 4ac all over 2a.
I had to go back into this race class. Like,
There's also one to Dr. Dre.
what?
And when I found that one, my daughter, who was 6 at the time, wandered around the house going, 2A, 2A. It's by Miss Callahan. I love her. I follow her on TikTok. Okay, so we just plug in our values. X equals the opposite of B, opposite of 7. Plus or minus the square root of 7 squared minus 4 times a of 1 times c of minus 16 divided by 2 times a, which is 1. I always fill it in and like color code it, because it helps my brain make sure I have 2 B's, 2 A's, and 1 C. But that's just me. That's a me thing, not a math thing. I find it helpful. This exhibits one of the downsides to this class is we don't get to use calculators. First semester, we don't get calculators. So try and do it without. So we get x equals negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times negative 16, positive 64, all over 2. Give us a little more space here. And we're going to leave this in radical form. Like we're going to do negative 7 plus or minus the square root of 113 over 2. And this is our answer. We do not have to go farther than that. We're not looking for specific values. Okay, good little. Okay. Oh, we're doing excellent on time. I love this. Okay. So that one's really challenging. That one's challenging today. I feel like that one's one of the harder ones today. And I think the reason this one's harder is because we don't have calculators. So we have to be able to do some of this mental math. And ideally remember this. Okay. Sorry, I've got to zoom out to be able to get space to the right so we can actually see this one. So this one has all kinds of fractions. Ew. Gross. We hate fractions, right? What's the shortcut way to get rid of a fraction? Multiply by your denominators. If we multiply absolutely every term by 20, we will have no more fractions. Where'd I get 20 from? 4 times 5. You can do it individually. You can do everybody times 4. You can do everybody times 5. It's the common multiple of 4 and 5. Yeah. Yes, common multiple. It is, in fact, the least common multiple. But any common multiple works. So if we multiply every term times 20, I've not changed my equation, and I've made it way easier to deal with. Because this becomes 15x, because 4 cancels out here. 3 times 5. That doesn't work, because that's not in the denominator. Never mind, sorry. Plus, my brain stopped for a second there. Plus 100. If it's in the denominator, we can cancel out. That one I can cancel out to be a 4. 8x minus 20. So this one is significantly less gross. By multiplying by the common multiple of my denominators, I can get rid of fractiony goodness. Because not everything needs to be pizza. And now we're into solving exactly the way we were before, which means we're going to do what? Subtract 8x. What made you guys pick 8x over the 15? Because if you move the smaller one, you have less negative numbers to deal with. Absolutely valid if you want to move the 15. Just watch out for negative numbers. Just pointing it out. And then we're going to subtract the 100 from both sides. It's going to leave us with what?
7x equals negative 1.
Which means x equals what? Is it going to simplify? Nope. You could put it as a decimal. More power to you if you want to do that. But why? Making your life harder. Leave it as fractions. Fractions are fine. We worked so hard to get rid of the fractions. Okay? Are we feeling okay on that? Sure? Okay, I'll take sure. Because now we're going to put them in the denominators. And just zoom in so we see one. What can we do here? It's a fraction. So how do I get rid of fractions? Multiply by your denominators. If I multiply this side, 2x plus 5, and this side by 2x minus 4. This is your cross multiply where we use the butterfly. We can get rid of the fractions. Because what we're doing is multiplying by that common denominator and just like canceling this out in the process. I'm multiplying by both of those pieces. And the denominators cancel out. So what we're going to have when we do our multiplications over here, 6x minus 12 equals 14x plus 35. That was a lot of jumps right there. Are we okay? I'm going to rewrite 35 because it looks weird. Okay. Now what are we going to do? Subtract 6x from both sides. And move the 35. There we go. Which gives us negative 47 equals 8x. Feel free to fact check me on it. Which we get x is what? Negative 47 over 8. When we have x's in the denominator, we have one extra step we need to think about. We have to check our solution because what can my denominator not be? What can we never ever divide by? 0. So is 47 over 8 going to make 0 out of either of those two denominators? No, because it would take a whole lot, like that's a whole lot of, right? But whenever x is in the denominator, you gotta spot check it, okay? Check and make sure we're not making our denominator 0. This would be like, we spent a whole chapter on this in algebra 2, all right? Okay. Let's do another one where we have fractiony goodness. It's okay. You're allowed to say that there's no such thing as fractiony goodness. Pizza. Pizza's when it's fractiony goodness. Or pie. Or anything in which you cut it in slices. I'm with you. That's the only fractiony goodness. All right. What's your instinct on this one? Say it again, because I heard a lot of ums and one thought in it. You can try, yeah, if you want to go ahead and get these to a common denominator and add them so that you can cross, that is absolutely a valid strategy. So if we're looking to get these to a common denominator on this side, let's start with simplifying this guy. Pen is being a jerk again. So you can factor out a 3 here. So this is minus 5 over 3 times x minus 3, right? 4 over x minus 3. So if we want to add these guys first, what's this one missing? Just a 3. That is an absolutely valid strategy. Not your only option, but absolutely valid. So this gives us a common denominator of 3 times x minus 3 and minus 5 plus 12. 7. And then we are into exactly what we did before. We're gonna do like a cross multiply situation, or butterfly, or multiply by your denominators. However works for your brain. Whatever we do, we should wind up with, let's see, 6 times 7 is 42. And, all right, yeah, okay. 15 x minus 3. You made me question myself. And 15 x minus 3. As long as you wind up somewhere around here, we should be good. Oh, I hear lots of honks. So this side I did times 6. This side times 3x minus 3 if you do it as butterfly. Or times 2 times x minus 3 times that least common multiple of our denominators. The denominators cancel out. So if you do by the least common multiple, which is this guy, this piece and that piece cancel. This comes down to 2. And then this 3 cancels out with this, that. And we'll get to the same piece. We'll get to the same answer. So either way is fine. Yes, ma'am. So you can either wind up at the 42, 15x minus 3, or you can wind up at 14, 5x minus 3. They're the same thing. Right? Or did I miss a piece? No, that should be right. Yes, because 14 times 3 is 42. They mean the same thing. If you cross multiply, you wind up here. If you multiply by the least common or the common multiple of our denominators, you get here. We're gonna get to the same answer. It's not gonna be pretty, and that's okay. So pick one. What's your next option? What are you gonna do? You could absolutely divide right now. You're gonna get fractions, and that's okay. Your other option is to distribute. Okay? Again, many, many pathways to get to an answer. So you could get 14/5 equals x minus 3. I do recommend distributing, because then we're going to have 42 equals 15x minus 45. And that's easier to deal with. $87 equals 15x, and then we won't have to simplify as much? Yeah.
The way that I did it was like, since we did like 3x minus 3,
Uh-huh.
I just crossed them out there and then just didn't do the other.
As long as you wind up here, you're fine.
Okay.
Yeah, yeah. There are, at this point, from here to the end, there's about 12 different paths. Whichever way your brain takes you, as long as you wind up with 87 over 15, or simplified would be 29 over 5. So simplified 29 over 5, or 87 over 15. What we get? So like we're stuck there, or we didn't get it. So we got here. So now we're trying to get x by itself. Whatever path you choose. So divide by 15, that's going to give you a fraction. So that's going to give you something like this. You're going to get 42 over 15 equals x minus 3. So then what do we do to get it by itself? It's already being subtracted by 3, so what are we doing?
Add by 3.
Add 3. So we have 42 over 15 plus 3.
Is that how you got like the bigger number?
Then you're going to have to common denominator and add those two pieces together. Okay? So we will do a little bit more of that tomorrow. And you guys can start on 2-1 because it's the same kind of stuff the whole way through. We'll just practice more simplifying. All right?
How come I got one? I only got one.
Oh, because I didn't get. I was like, I didn't get my whole pile passed back out. It's gonna be. I'm doing my best. I was like, they're all here. This is the rest of my pile. I'm just gonna start doing it during passing period because that's the only time I've got. So I've got it. I can see if I can find a minute. I got more.
I don't know if I turned 1.3, so I redid it.
Okay. I was like, you can always check on Skybird.
Yeah.
I try and update it as soon as I can. I do have like 6 of them that I don't have in yet. Let's see if I got more in here. I am at some point just like organize this and make it way easier.
Wait. Yeah, that, or yeah. That was the first time that we ever spoke.
Alright. And then in my pile of things I haven't got yet. I have the one that you gave me yesterday. I've got right here. Okay, that's the 1-3. And then
That is like a gross name.
right there. I've got it. So I've got 1-3 and 1-4. I'll get to those fifth period in a minute. It's in my new pile.
I'm trying to help.
Because that's how I organize it. Piles.
I said you're lucky. I'm lucky you even texted. But I did. You did text me. Can I see too? I don't believe you.
I was like, I think they're not.
Not hard, but
Hey.
because I know we went from like 20 an hour.
All that is
I'm really hoping it's just that the person who designed the homework finally had a realization that they've been a jerk. They're not the worst. I single paid for me with all my work. So this is homework 2-1. 1 second. Ish. Less than a minute. 44. 45. Yeah, less than a minute.
I need to post it like
Yes.
Yeah. These are not bad. You'll be fine. Have a great rest of your day. See you tomorrow.
That's okay. I've got
With smile.